Today we're going to do 6.4 applications of vectors in geometry. This is the very last topic for the year actually. So let's just get right to it. Okay, first and foremost we are on page 198 and we are going to do try it 24. Okay, first and foremost the question asks if we can show that the vector AB is equal to the vector DC. So first let me say that the vector AB is equals to AE plus EB. And AE plus EB is also equivalent to EC plus DE, which can also be equivalent to DE plus EC. And what is DE plus EC? DE plus EC is the same as the vector DC. So in this case, we have actually shown. For part B, they justify that ABCD is a parallelogram. So in a statement, since the vector AB is equal to the vector DC, therefore, when two vectors are equal, they're the same direction, same magnitude. So in this case, AB is parallel to DC and they have the same magnitude as well. So the length of AB is equals to DC. Then the diagonals bisect each other. And this is given down here. So therefore, we say that hence ABCD is a parallelogram. Now we look at page 199, try it 25. So what we have is they would like us to show that PQ is parallel to AC and that PQ is half of AC. So to make our life a bit easier, first I'll say let the vector AB be equals to the vector U and the vector BC is equals to the vector V. So what we're doing here is AB, this entire thing here, is equals to the vector U and the vector BC is equals to the vector V. Alright? Okay. So now what I can say is this, the vector AC is equals to U plus V. Now next, I also want to look at the vector PQ. So the vector PQ, so since right all PQRs are the midpoint, so PQ is actually PB plus BQ. So PB, alright, will be half of U and BQ will be half of V. So PQ equals to half of U plus V. If you factorize out the half, thus I have shown that PQ is equals to half of the vector AC. So since it's half, PQ is K times or half times of AC, hence I say that PQ is parallel to AC and that PQ is equals to half of AC. Okay, now let me do part B. Alright, so now for part B, what happens here is this. I need a bit more space. So let me just draw a line over here. Okay, for part B, to show that PQRS, okay, so similarly, if we were to consider triangle ACD, okay, A, C, and D, alright, so I will say that I will be able to show that SR is parallel to AC and SR is half of AC. So therefore, PQ in this case will be parallel to SR and PQ will be equals to SR. Therefore, we can say that PQRS is a parallelogram. Now we move on to page 200 and try it 26, a slightly longer question. Okay, just take some time to read through the question and I'll move right into expressing PT in terms of U and V. So first what we can start is that we can start with OQ. So the vector OQ is actually equals to vector OP plus OR. So the vector OQ is equals to 4U plus 3 of vector V. Then it is given that OT is equals to 2/3 of OQ. So hence OT is 2/3 of 4U plus 3V, which we found from above down here. Now next, PT. Okay, so if I want the value of PT is actually equals to PT is equals to PO, alright, plus OT. So what is PO? PO is negative 4U and OT is what we have found above down here, and OT itself is 2/3 of 4U plus 3V. So if you open up the brackets and simplify, what you get is PT equals to negative 4/3 U plus 2 of V. Now I will move on to part B. For part B, what they want is prove that PT and M lie on a straight line. So basically what we're trying to say is, can I prove that if I want it to be on a straight line, I'm trying to prove that PT is equals to K times of PM, because they will share the common point P, and then they'll be parallel. In this case, if they share the same point, which is P, then it will be that the P, T, and M will all lie on the straight line. So first we begin with PM is equals to PQ plus QM. So then that gives me PQ plus half of QR. Okay, because it is given that M is the midpoint of QR. So what we have is PQ is equals to 3 of V plus half. Okay, so if OP is 4U, so therefore QR, so OP is 4U, QR will be negative 4 of U. So here will be negative 4U. So what we'll get here is negative 2U plus 3V. Then from part A, I know that from part A over here, we know that PT is equals to negative 4/3 U plus 2V. So if I were to factorize 2/3 here, what I will get is negative 2U plus 3V. So you notice we have something common here, negative 2U plus 3V, negative 2U plus 3V. Hence, I can conclude that PT is equals to 2/3 of the vector PM. So in this case, I say the PT vector is parallel to PM. Okay, they have a common point P. So hence, okay, P, T, and M all lie on the same straight line. Okay, now we move on to page 202, exercise 6.4, and this will be question 1. Okay, so now we want to express DF in terms of U and V. So what we know is that BA is the vector U, BC is the vector V, and this is a midpoint of this, and this is the midpoint of this, and E is the midpoint of A and C. So now I'll begin with for part A. first and foremost, I will say that df is equals to db plus bf. So db plus bf. Okay, that is df. And what we have is db will be negative half of v, and bf will be plus half of u. So I've completed that for df. Now what I need for EA. So EA will be equals to half of CA. So what is CA? So CA can also be CB plus BA. So let me write that down. So CB will be negative V, then plus BA is plus U. So what I'll get here is that EA is negative half V plus half U. Now they say show that AFDE is a parallelogram. Since I have found that the two values for DF and EA, they are the exact vectors. So let me write that down. So DF is equals to EA. So what this implies is that the line DF is parallel to EA, and that DF is equals to EA. Once you have a pair of parallel sides and they are parallel, they are the same exact length, you can conclude that AFDE is a parallelogram. Okay, now we move on to question 3, which can be found on page 202. Okay, first I'll begin with AB. So first I know that OA, be careful, it's not OP that's a vector A, is the whole of OA is A, the whole of OB is the vector B. So if I can begin, I will say this, that the vector AB is equals to AO plus OB, and AO is negative A plus B. Now, next one we have PQ. Okay, PQ, how we'll get is PQ is actually OQ minus OP. PQ or is equals to PO, alright, plus OQ. And what is PO? PO is negative 2/3 A. Then plus OQ is plus 2/3 of B. So now we are almost there for part B. Okay, so first and foremost, I will say that PQ, alright, is from over here. If I factorize out 2/3, what I get is negative A plus B. Does this look familiar? This and this are the same value. So hence PQ is actually, I can write down a statement that PQ is actually 2/3 of the vector AB. Therefore, I can state that since PQ is K times of AB, in this case the K value is 2/3, I can state that PQ is Okay, we're on question 8 of exercise 6.4. This can be found on page 203. So now we begin. Okay, first we will say that it is given that AD is 9/5 of the vector BC. So therefore, I can conclude that AD is 9/5 of BC and that AD is parallel to BC. Okay, all this from here because AD is K times of BC. Then I will say this, since these two angles here are equal, so I'll let angle BAC is equals to X, angle CDA also equals to X, and I name angle ABC equals to Y. So first and foremost, I will say that angle DAB over here, okay, since these two lines are parallel, and this we name it as angle Y, so angle DAB is 180 degrees minus y. So this angle over here is 180 minus y. Then we know the angle DAC is equals to 180 minus y, as we found over here, minus x. So therefore this angle over here is 180 minus y minus x. Similarly, for angle ACB, if you consider x and y, this angle over here is 180 minus y minus x. Okay, so this one is actually the angle sum of triangle ABC. So therefore, if I say that these two angles, if you notice, is 180 minus y minus x, 180 minus y minus x. So angle DACB is equal to angle DAC. Now, I will now look at part B. Explain why ABC and DCA are similar. Okay, so in triangle ABC and triangle DCA, I know the angle BAC is equal to angle CDA. This is given. So I also know the angle ACB is equals to angle DAC. This one is found in part A. So therefore what I can say is that triangle ABC and triangle DCA are similar. Okay, and the reason being 3 pairs of corresponding angles are equal. Okay, now we move on to the very last part. Okay, part C. Find the area of triangle, the ratio of area of triangle ABC to the ratio of triangle DCA. So if you notice, all right, since these two lines are parallel, so if you just extend them out a bit and you draw here, this will be the height. Okay, so that means, right, what I'm saying is that triangle ABC, all right, this is the base and this is the height. Similarly, for triangle ADC, all right, this is the base and this is the height itself. So therefore they share the same height in this case. So now, right, what I'll say is that for part C, area of triangle ABC over area of triangle DCA is equals to half times base times the height, okay, and half times the base, which is DA, times the height. If I eliminate the half and the H, I am left with BC over AD, and this, right, we can find from over here. So it's not 9 over 5. In this case, BC is on top, so it's 5 over 9. And that is the last example